Hello, I'm Arda. With my friend Hassan, we will talk about improving XKMC using alternative explainability methods for enchant interpretability in K-means clustering. Clustering is unsupervised, so we have no labels to explain why data points group together in algorithms such as K-means. In fields like healthcare and finance, people need clearer and trustworthy results. Therefore, making explainable clustering is a critical topic. To work on that issue, we choose adult income dataset to create clusters about income levels of a person. We also perform pre-processing. XCAMC is an approach that uses a single decision tree to explain KMs. However, it lacks deeper feature level insights, so there was room for improvement. Our solution is a framework that layers multiple explainability tools on top of XCAMC by combining various approaches, so we make clustering clearer. Let's look at the approaches we implemented. Interactive tree plots help people see how features like age and education split data into clusters. Also, feature importances indicate which feature is important. SHAP shows how each feature contributes cluster labels. We use ANOVA to confirm which numeric feature differs significantly across clusters, and chi-square to see which categorical factors matter. Finally, we use GPT to translate and summarize our findings into plain language to make easy understand. Also, we run a step-by-step survey with 12 participants who are both technical and non-technical to measure how much they understand and their confidence at each stage. These tables reflect how user ratings improve from XGAM's baseline to our final enchantments. It highlights a drastic increase in participants' understanding. At the baseline, most users struggle to understand the results. However, by the end of all steps, their understanding improves significantly, so it reached a near perfect clarity ratings. Our enchantments bridge the gap between raw clustering outputs and practical needs of stakeholders by improving XKMC. Next steps include testing larger participant pools, tailoring details on users in different technical levels, and extending this framework to other algorithms. Now, my friend Hassan will continue with the code base.
Hello, I will explain the demo of the code. Here's the data preprocessing for clustering. We handle the missing values by filling them the categories one with unknown and the numericals one with median and using a standard scaler. Here is the determining the K value by using elbow and sledge score. It's 3, and by my experience, I made the same conclusion. Uh, Results for baseline, as you can see, the cluster one is very low sampled. So to outcome this, we will use some feature selection methods. The accuracy is 72 here, and by using SPCA and MCA, this is good for noise, and this is good for categorical features. An alternative approach to using only PCA. We gotten a 81% of accuracy. This is now our new cluster plotting, and this is the real plotting. Baseline model, the XKMC method is due to my compatibility issues with the library on my local machine caused by NumPy version mismatches. This caused by class learn library. So I made an approach for my local machine. I trained a decision tree. It's basically the same approach as the XKMC does. Now, here again, some data preprocessing for the baseline explainable clustering method. You can see the tree as text here and visualize it as here. And uh, here is the improvements on explainability that are contributions. This is dynamic tree. We use the tree visualization library for this. As you can see, it's more detailed, and this is its feature importance graph. By combining these, it's very much more understandable than the baseline approach. And we added SHAP by using clusters classifier uh, library module. We make this none and default it's XGBoost classifier, and we can use SHAP importance plotting on this classifier. by using again some tools from the Clustern library. As you can see, SHAP gives us a more detailed information. As you can see, education sometimes results with lower income and such as hours per week, blue collar jobs maybe, and maybe other situations. But as you can see, correlations are seen and the average remain averaging income. These are some automated comments for the other stakeholders, non-technical stakeholders. These are the numerical analysis for like ANOVA and numerical cluster descriptions and key square uh, analysis. These are again some comments. Here is the generative AI explanation. We implement generative AI to make the clustering more understandable again for the other stakeholders that are non-technical. It generates like sentences like this.